Hello and welcome to Aspire Test Prep's instructional video on differences of squares and perfect squares. Aspire Test Prep offers online SAT and ACT tutoring for students and test prep classes for high schools. You can find out more at www.aspiretestprep.com or you can call 646-269-6250. Now, on this video, we're going to go ahead and go over questions from a worksheet that you can access through the aspiretestprep.com website. You can go on there, click on Prep for Free, and go to Differences of Squares and Perfect Squares, and under Practice Problems you'll find this worksheet. You can go ahead and try to answer them on your own and check out the answer key, see which ones you still don't understand, and refer to this video for help. Starting with question 1. Question 1 gives us an expression and says, which of the following could be the value of A? Well, in order to know how to effectively handle this problem, we need to realize that if we had something like x plus y times x minus y, and we were to FOIL it out, we'd get x squared, first times first, outer times outer, inner times inner, and last times last, and we'd get a situation where the outer and inner terms cancel out. That's going to happen whenever you have a situation where you have this type of setup, where let's say c plus d times c minus d. We already know in advance that we'd get c squared minus cd plus cd minus d squared, and once again those two middle terms would cancel out. So you should be in the habit, whenever you see a setup like this, w plus z, w minus z, to just automatically go into w squared minus z squared. Or the converse, if I saw something with this type of a setup, u squared minus r squared, to automatically know that this would factor the u plus r and u minus r, which is just doing the same thing we did, but in the opposite order. Now, why is it called the difference of squares? Because each of these is a perfect square, and there's a minus sign in between, which makes it a difference. So now, having a firm handle on that, when we see something like 16x squared minus 36, we know that's going to factor to 4x plus 6, 4x minus 6. We're being asked about the possible value of a, which is the first of both of these numbers, and a could be equal to 4. Looking at number 2 now, we have 25 minus 49x squared. Notice that we have a perfect square here and a perfect square here with a minus sign in between, and this is going to factor to 5 plus 7x and 5 minus 7x. So the question is asking us what could be the value of d, and the value of d could be 7. So looking at number 3 now, we have a perfect square, another perfect square, because the square root of each of those is 10x and 9 and 3y also, and we have a minus sign in between. So literally, this is a difference of two perfect squares, and it's going to factor to 10x plus 3y, 10x minus 3y. And if you're unsure of that, you can FOIL it back out and see that, yes, indeed, it does factor. It does FOIL right back out to our starting expression. So what could be the value of e? E is in the spot of the first coefficient, so e is going to be equal to 10. Going to number 4 now, we're just getting a little more fancy with it. We're starting with a difference of two squares. Now this is obviously a perfect square because it factors to x, but if we want to, we can think of the c as a perfect square, because if the square root of it is square root of c, right? So the two yellow things do have square roots, so we could factor it to x plus square root of c times x minus square root of c, and that gives us answer D. Going over to number 5, it's kind of the same thing. This is definitely a perfect square because the square root is x, and this we could think of as a perfect square because the square root could be radical g. So the square root of the first plus the square root of the second, the square root of the first minus the square root of the second, and we're done, and our answer is choice D. Going over to number 6, well, this is a perfect square because the square root is x, And if we want to think of this as a perfect square, we can, because the square root of that is actually the fourth root of w. Now, how do I know that the fourth root of w is the square root of the square root of w? Because the fourth root of w can be rewritten as w to the 1/4 power, right? If I square that, I have w to the 1/4 times w to the 1/4. And if I'm squaring it, which is what we're doing here, you actually are adding the exponents in a situation like this, so you get w to the 1/2, which is the same as the square root of w. So we just proved that the fourth root of w is the square root of radical w. So to factor this, it's the square root of the first plus the square root of the second, the square root of the first minus the square root of the second, and we're done. And that matches choice C. Going over to number 7 now, we're solving for variables on these questions. So for number 7, we can just add 9 to both sides. X squared equals 9. Take the square root of both sides, and you get x equals not just 3, but plus or minus 3. So that's why it's important that they're telling us in the problem x is greater than 0, because that's telling us to pick the positive of the two answers, and x equals plus 3. On this one, we have h squared minus 81 equals 0. We can add 81 to both sides. H squared equals 81. Take the square root of both sides, and we have h equals plus or minus 9. We were told that h is positive, so h equals plus 9. And going over to number 9 now, we have p squared minus 121 equals 0. Add 121 to both sides. Take the square root of both sides, and you have p equals plus or minus 11. We're told that p is negative, so the answer is negative 11. Alrighty, going over to number 10, we're not dealing with differences of squares anymore. We're dealing with perfect squares. So just to kind of talk about the difference between the two, if I had x plus y times x minus y, like we said before, foiling it out, we'd have x squared minus xy plus xy minus y squared, and we'd get a dynamic where every time we do one of these, the two middle terms are going to cancel out, leaving you with x squared minus y squared. However, if I had x plus y times x plus y and I foiled that out, I'd have first times first, outer times outer, inner times inner, last times last. So something similar is going to happen, but it's not that the two middle terms are going to cancel, it's that the two middle terms are going to always combine together to double of whatever you had for the outer and inner multiplication. If we had, for instance, x minus y times x minus y, first times first, outer times outer, inner times inner, last times last, and you get x squared minus 2xy plus y squared. So when you have a perfect square, you're going to have this idea where there's some doubling in the middle term of the trinomial. Plus 2xy for the first one and minus 2xy for the next one. So now, once you get to know this idea, you can test for the three attributes of a perfect square. What is a perfect square? Well, to test out whether a trinomial is a perfect square, the first term must be a perfect square. So for instance, that happens right here in yellow and right here in yellow. Next, the third term must be a perfect square, and that happens right here in green and right here in green. Now, when you're going ahead and testing whether they're perfect squares or not, you should go ahead and take the square root. So the first term for both of those was x, the square root of the first term. The square root of the third term for both of those was y. Now, the last criteria is that the middle term has to be equal to 2 times the square root of the first term times the square root of the third term. 2 times the square root of the first term times the square root of the third term. So that's 2 times x times y, and that is what we had for both of our expressions, minus 2xy and plus 2xy. So when you're dealing with the attributes of a perfect square trinomial, you're going to have the first one is a perfect square, the last one's a perfect square, the middle one is equal to 2 times the square root of the first times the square root of the third. And if you have a plus sign right here, that would factor to x plus y all squared. And if you have a minus sign right here, that would factor to x minus y all squared. So does that fit for this expression? Is the first one a perfect square? Yeah, because the square root of it is 4x. Is the third term a perfect square? Well, yes, because the square root of that is 6y. Now, last but not least, is the middle term a perfect square? Right here, 48xy. Well, not is it a perfect square, but is it equal to 2 times the square root of the first times the square root of the third? And that's 8 times 6, which is 48. So it's 48xy, and that's exactly what that term is. So we just ran the perfect square trinomial test on our expression, and once you know it's a perfect square, it's going to factor to that square root of the first term, which was 4x, and the square root of the third term, which was 6y, all squared. Now this plus sign right here would have been a minus sign if we had a minus sign right there. Otherwise, everything else is the same. So the answer is 4x plus 6y all squared, and that's choice A. For number 11, is the first term a perfect square? Yes, because the square root is 5a squared. Is the third term a perfect square? Yes, because the square root is 3b squared. Is the middle term equal to 2 times the square root of the first term times the square root of the third term? Well, that would give us 2 times 5 times 3, which is 30, a squared b squared, and that perfectly matches what we have right here. But we do have this minus sign, which means that instead of having this thing factor to 5a squared plus 3b squared, it's going to factor to 5a squared minus 3b squared. And of course, that's all squared because we just determined that that trinomial was a perfect square. So now we have the answer for number 11 is choice B. Okay, going over to number 12. Is this a perfect square? Well, is the first term a perfect square? Yes, because the square root is a squared. Is the third term a perfect square? Yes, because the square root is 4b squared. And is the middle term equal to 2 times the square root of the first times the square root of the third? And that would give us 8a squared b squared. And that's exactly what we have. So by running the perfect square test, and we notice that there's a minus sign right here, so we're going to put a minus sign in the middle. That gives us a squared minus 4b squared, all squared, and that's a b right there. And we've officially factored that one, and that gives us choice D. For number 13, is the first term a perfect square? Yeah, because the square root is 3x cubed. Is the third term a perfect square? Yes, because the square root is 5y to the fourth. And is the middle term equal to 2 times the square root of the first times the square root of the third? And it is, because it's 6 times 5, which would be 30 x cubed y to the fourth. So we have the trinomial will factor to 3x cubed plus 5y to the fourth. Notice that there's a plus sign in the middle, so we go with a plus sign, and it's all of that squared. So our answer here is going to be choice C. Moving right along, we have number 14. Is the first term a perfect square? Yes, because the square root is 4x squared. Is the third term a perfect square? Yes, because the square root is 5y squared. Now, is the middle term equal to 2 times 4x squared times 5y squared? Well, 2 times 4 times 5 is 40, x squared, y squared, and that's exactly what we have. We have a minus sign, so it'll factor to the first square root minus the second square root, all squared. 4x squared minus 5y squared, all squared, which is choice D. Going over to number 15, we have a different question that says that this expression can be factored to that. Now, if they're telling us what it can be factored to, then we can go ahead and just expand that out. 2x minus 4y, 2x minus 4y, and we have first times first, outer times outer, inner times inner, excuse me there with my zooming, inner times inner, and last times last, and we have 4x squared minus 16xy plus 16y squared. And so we have the 4x squared matching the 4x squared. We have the 16y squared matching the 16y squared. And we have negative 16xy matches the negative axy. So we now know that a equals 16. And the answer to this question would be 16. Going over to question 16 now, we know that they're telling us we have 4z minus 8w. Now z is said to be x squared plus y squared. W is said to be xy. If we distribute, we have 4x squared plus 4y squared minus 8xy. And having gone through so many perfect squares together, you develop an instinct where we know that it shouldn't be 4x squared plus 4y squared minus 8xy. It should be 4x squared minus 8xy plus 4y squared. Now, according to our perfect square test, we're seeing that the first term is a perfect square because the square root is 2x. The third term is a perfect square because the square root is 2y. And the middle term now has to be equal to 2 times 2x times 2y, and that's 8xy, which is what we have. So we know that it'll factor to the square root of the first minus the square root of the third, all squared, 2x minus 2y all squared, and that's answer A. Going over to number 17 now, we've got, zooming in just a little, 36c plus 72d, and we can go ahead and substitute in what we have for c, a squared plus b squared, and what we have for d, which is ab, and distribute it out. We have 36a squared plus 36b squared plus 72ab. Like I said before, our instinct would be to kind of recognize that if it is a perfect square, the terms would be kind of in a slightly different order. So we're just reordering it here, and then we go through the perfect square test. So is the first term a perfect square, 36a squared? Yeah, because the square root is 6a. Is the third term a perfect square? Yeah, because the square root would be 6b. And is the middle term equal to 2 times 6a times 6b? And that would give us 72ab, and that's exactly what we have. So because it passed the perfect square test, we know it factors to the square root of the first plus the square root of the third, and the plus comes from the fact that we have a plus right there. So that's our answer, 6a plus 6b all squared, answer B. And our last question is number 18. We've got 9j plus, minus 2f, and f is 81gh. So if we go ahead and expand this out, we'll have 81g squared plus 81h squared minus 162gh. Rearrange it, 81g squared minus 162gh plus 81h squared. And does this pass the perfect square test? Well, the first term is a perfect square because the square root is 9g. The third term is a perfect square because the square root is 9h. And the middle term should be equal to 2 times 9g times 9h, and that's equal to 81 times 2, so 162gh, and that is what it's equal to. But we have a negative sign right here, so it's going to factor to not 9g plus 9h squared, instead 9g minus 9h, all squared, and that matches choice H. Thanks for watching our instructional video on differences of squares and perfect squares. What you can do with this and any of our lessons is find the worksheet on aspiretestprep.com and click on Prep for Free. You find the worksheet there, go ahead and do it on your own, check the answer key, see what you know and what you don't know, and if you need to, you use these videos for the actual instruction on how to do some of the problems. If you enjoy this video and if you're getting a lot out of it, you can thank us by recommending our online tutoring to any of your friends who are prepping for the SAT or ACT, or asking your school to sign up for Aspire Test Prep's SAT or ACT classes for their students. And you can get any of our information at www.aspiretestprep.com. Thanks very much.